Alright, so in today's flip lesson, what we're going to be talking about is section 5-2, using the intercepts. First, we have to understand what it means to be an intercept. For example, in football, ball's thrown by the quarterback, it's up in the air, it's intended for the wide receiver, defensive back, safety, cornerback, linebacker, whoever it might be, intersects the path of the ball and intercepts the ball, takes the ball away. So, one of those visual examples for you to be able to see. In math, an intercept is where something crosses another object or another point on a line. So, just as a refresher as well, we have our x-axis going horizontal. We have our y-axis going vertical. So if I'm looking for the x-intercept, I'm looking for where my line crosses the x-axis. If I'm looking for the y-intercept, I'm looking for where my line crosses the y-axis. So once again, my x-intercept will cross the x-axis. My y-intercept will cross my y-axis. So as an example, we'll take a line and we will sketch it out. So, as a way to review as well, going from left to right, this line is going down, which means that it will have a negative slope. Looking at this on an intercept perspective, I need to find out where the two intercepts are. So, my x-intercept and my y-intercept. My x-intercept is where it crosses the x-axis. So if I go over, this line is going to be crossing my x-axis at over 3 spaces. So we write this. Keep in mind, x, comma, y is the nomenclature we're using to be able to represent a point on a graph. So the x value, I'll go 3 to the right, and I'm not going up or down, so my x-intercept should be 3, 0. Now my y-intercept is where it crosses the y-axis. So I'll start at my origin. I'm not going to go left or right. So it is 0, and then I'm going to go up 1, 2, 3. My y-intercept is 0, 3. All right, so once again, x-intercept 3, 0, because we start at 0, move over to 3. We don't go up or down. My y-intercept, we start at 0, don't go left or right. We go up 3, and 0, 3. So this is a fairly easy example. Example number 2. Assuming that this goes exactly through this point, we need to be able to find the x and the y-intercepts. So, x-intercept is where it crosses the horizontal line, the x-axis. So if I start at 0, I'm going to go 1, 2, 3, 4, 5 to the left, which will give me a negative 5. And I'm going to go 0 up or down, giving me negative 5, 0. For my y-intercept, left or right, 0. And going up, I'm going to go up 1, 2. Therefore, in this problem, my x-intercept is negative 5, 0. My y-intercept is 0, 2. These are the 2 points where it is intersecting or intercepting the graph. Now, the next example is a completely vertical line. We had talked about this in section 5-1, where it's positive, negative, 0, or undefined. This is an undefined slope because it's going completely vertically. From here we need to be able to find the x and the y-intercept. Now, if I start at 0, I can go left 1, 2, 3. And we can go up or down 0 in order to get to that point. The tricky one is the y-intercept. Where does it cross the y-axis? Well, if we look at it, these two are going to be what are called parallel. They have the same slope. They parallel, so they're never going to touch each other. So we just say that it does not exist. So we do not have a y-intercept. They are never going to cross each other. Now, this is the way to solve these using a graph. A lot of the times you're not going to actually have a graph to be able to look at. Most of the time what you'll have is an equation. So you have 2x plus 3y equals 12. If you go back to section 5-1, this is also our standard form of an equation. ax plus by equals c. We'll have this up here as a reference for us to be able to use. So now we're actually going to use this. If I want to find the intercepts, the x and the y-intercept, I can take what I know about the graph and be able to use it in an equation. So on an x-intercept, we have the value of x, comma 0. Our y-intercept is always going to be 0, comma y. So in the last two problems, if you go back, you can notice that the x-intercept was always a number, comma 0. Y-intercept was always 0, comma a number. So we can use that to be able to find out our x and y-intercepts fairly quickly. So for our x-intercept, what we're going to do is we're going to leave x as it is, and we're going to change y to 0. And what does that do? That takes 3 times 0, which is 0. And now you should be able to solve a one-step equation. So, my x-intercept should be 6, comma 0. And we're taking that 6, plugging it back in. If I were to check my solution, 2 times 6 is 12, 3 times 0 is 0, 12 plus 0 gives me 12. Now on the y-intercept, we're doing the exact opposite. We're going to plug in 0 for x, plug in our y for y. 2 times 0 is 0. 3y equals 12. So y equals 4, which means that our y-intercept is 0, comma 4. So we have both of our x and our y-intercepts just by taking and plugging in the zeros. Now, next what I'm going to teach you is a little bit of a trick to be able to solve these problems a little bit quicker. So, say we have 5x plus 10y equals 30. What we want to do is we want to be able to find the x-intercept and the y-intercept. So x-intercept, y-intercept. We're going to create two different cases. The first case is we want to be able to find our x-intercept. Well, we know that x is going to be there. We know that our y is going to be 0, so we're going to use something called the cover-up method. If I cover up that next value, that's basically replacing the y with 0 and multiplying. 0 times 10 is 0. So this is going to end up canceling out, or zeroing out. So now what I'm going to do is I'm going to cover this up and write what's left over. I have 5x equals 30. On my y-intercept, I'll do the same thing, but for my x, I'm going to replace it with 0. So now I have a positive 10y equals 30. So I can take both of these now, and I can solve them fairly quickly. Divide by 5. So my x-intercept will equal 6, 0. Remember, I'm just taking that answer, plugging it back in. My y-intercept should be 3, so I can rewrite it as y-intercept equals 0, 3. And I've got both my x and my y-intercept just using the cover-up method. Very helpful thing to do, very easy once you get the hang of it. It's a difficult process until you start to understand the cover-up method. So just to make it a little bit more challenging, say we have something like y equals 0.25x minus 1. As of right now, I don't have this in the standard form. What I'm going to try to do is I'm going to try to get it into standard form, make it a little bit easier for me to see. So I can take my x and I'm going to move it to the other side of the equation. The minus 0.25x will zero out. Remember, I want to have my x, then my y, x, then my y, and then my constant all the way to the right-hand side by itself, isolated. So I've got my equation. I can set up my x-intercept and my y-intercept. My x-intercept, I'll cover up my y. So negative 0.25x equals negative 1. And for my y-intercept, I'll cover up the x. Y equals negative 1. Well, that one's pretty easy. So that one's taken care of. Last part is being able to divide by negative 0.25. Negative divided by a negative gives me a positive. 1 divided by 0.25 ends up giving me 4. So my x-intercept should be 4, 0. My y-intercept should be 0, negative 1. And I have finished finding the x and y-intercepts based on standard form, section 5-2.